This is Algebra 1, Term 2, Lesson 2. And today we're doing three, actually more than three, but you'll see several activities regarding sequences. And the first one is going to be a 3-act task, placing toothpicks, and then we'll do some activities in slides, one of which really addresses the subscript notation. And then finally we'll finish it up with a Desmos activity. So let's start with the 3-act task. Your first slide just contains some toothpicks, and I'm just asking them to type something. What do you notice? What do you wonder? So they may wonder, what are we doing with these toothpicks? I don't have it so that you actually do use the toothpicks, but if you want to purchase toothpicks and have kids do this task themselves to build out this pattern that you're about to see, that is actually a great idea. They could also come to the boards and draw the pattern. So there's lots of ways you could handle this. I have given you very little in the slides. I'm going to link you directly to the task, and you can decide how you would like to handle it. Now the video that I'm going to give you for this task actually comes from this site, Tap into Teen Minds, and it's Kyle Pierce's video that we're going to be looking at. And this is one of many videos that they've used. This is the video that you'll be seeing. And here's how they handle it. They have all this different material, task template you could use. To be faithful to the inquiry process, though, my suggestion is to give them very little scaffolding and let them just play with it for a while and maybe offer those scaffolds later. Here's some kid wrote on a desk. Here's some kid wrote a rule and drew the pattern and so forth. This is the toothpick pattern the students will be working with. And so you could ask a variety of questions about this task. For Act 2, which would be watching that video and then describing what happened, would come here. The students would document their work and insert text, images, process, predictions, whatever, and you should instruct them what do you want them to do and what do you want on this slide. If you would like, you could delete these slides altogether and have this 3-act task not be part of their slides. That's totally up to you. I've given you some questions in the show notes that you might consider addressing with this task. This task could take, depending on how you do it, a short amount of time because it's pretty much a general pattern that is linear that they should be pretty comfortable with. So as little as 20 minutes, depending on how you handle it, up to an hour if you really want to get deep into it, produce a poster or do something like that. So this part of the assignment is kind of determine the length of your lesson for the day. So let's go to the next part. The next is using this notation, a subscript n, and answering some questions. So what is the domain of a function that represents a sequence? So we're reviewing some of the terminology we learned in the previous lesson. Of course, the domain is the positive integers, 1, 2, 3, 4, because we use counting numbers to represent the terms of a sequence. Is this arithmetic? And if so, what is the common difference? What is the first term? What is the 20th term? And is there a term that equals 107? Is there a term that equals negative 43? My suggestion is do not discuss this as a class, at least not initially. Give the kids time in their teams to work on this task, this particular screen, because you basically are getting a good feel for how much they have learned from the previous assignment and how much you need to step in and maybe reinforce if they're not getting this vocabulary and what these things mean. My suggestion, or the way I would have handled this, is I would give them anywhere from 10, maybe 10 minutes in teams to work on this task, and then I would solicit the teams. Like, okay, team 1, I want y'all to handle question 1, and y'all can come up here and write what you think it is on the boards. And so I would take the teams, one volunteer from each team, or you could take the whole team, it depends on how much time you have, and send them to the boards with their answers, and then we could discuss it as a class. Especially if somebody misses one, we want to make sure we know. Or we can also solicit volunteers, like let teams raise their hand if they want to answer a particular question. All right, so the next task is using the subscript to type equations. Now they can't do that in slides, but they can do it in Desmos Calculator, and they can do it in Graspable Math. So I'm going to basically send them to Graspable Math and ask them to retype this equation using subscripts. So let me show you how that works. When they go to math.new, it takes them to a whiteboard, and my students use this whiteboard the whole school year. Once I've introduced it, it's kind of free game, and the kids go here as often as necessary, particularly when they're trying to type mathematics to insert into slides or anything else. So here it gives you an equation already, but that's just a placeholder, so they're going to type over that. I'm going to start with A. So I'll just delete that, type A. Subscript is shift and then the button for underscore. And I basically put that on the slide in case they don't already know what that is. And then they're going to type N. Then they're going to hit the right arrow to get out of that subscript and type equals 3 plus 2 and then multiply by N minus 1. All right, they're going to click the check mark and that's going to place it on the canvas. Now they're going to screen capture just the equation and then they're going to paste that on the slide underneath the one that's already there. So basically these two equations represent the exact same sequence. One is in function notation, the other has the subscript notation, but they are equivalent. They just need to be familiar with both because both forms show up in assignments, on assessments. They're just going to see both all the time. So they need to be okay typing it and working with it in either notation. All right, the next screen, they're going to take the same function and they're going to find the first 3 terms. Now you could just have them type it here, but the goal is to get them to practice using the subscript notation on math.new. So have them go back to math.new and do A subscript 1 in math.new equals and put a number. They of course can use Graspable Math to do that because they can put in values of N and evaluate and see what they get. And they can also go to Desmos and use the calculator if they need it. So that's up to you what you want to give them there for supports. So again, we're just practicing and we're using the new digital whiteboard at math.new. And then the last slide, totally unrelated, is just some basic practice. They're going to visit Mathagon and fill in these question marks. This exact same graphic is on the screen. So when they click this link, it's going to take them to Mathagon. It looks like this. They are in the introduction to sequences and patterns. They may decide to go further, but tell them they don't need to. Once they get to arithmetic and geometric sequences, they have finished all they need to do. And I'm simply asking them to do this, fill in, put the numbers in here, and take a screenshot. Now you may notice mine has some words here that's telling them what to do, and that's because I've already opened up the entire activity. When they first go here, that will not be there. When they go here for the first time, that will not be open. If they do click up here at the top, there's going to be a spot that says show all. They can see everything, including these suggestions. It doesn't tell them the numbers, but at least it tells them what to do for those kids that get stuck. So you may not tell them that, but that is a help that's going to be there for them if they do get stuck. Once they get these answered, they'll take a picture of their work with all the numbers in place, and they will put it here. They'll get rid of this picture that has the question marks and put the one with their numbers in there. And that's concluding the slides. So the last activity for the day is the Desmos activity. And it looks like this. At least half your class period, maybe more, maybe longer, will be spent in this activity. This is a review of the concepts of the last lesson and earlier activities in this lesson. And it also has a very fun activity we call a polygraph. So this will be the first one they played in this class this school year. So the first thing they're going to do is tell me which of these could represent a sequence and explain their choices. I've given you some teacher moves here, some explanations that, you know, some things you could draw out of the kids here for discussion. I would pace your kids at this point to make sure they're clear on which one of these is a sequence before they proceed. Once you've answered the first screen, I would open the pacing and let the kids go, because they do need to work through this part alone just to see what they know. These are self-checking, but they don't display correct for the kids. So again, if you would display your dashboard and anonymize your dashboard, they can look up to see if they're getting their answers correct. And if they're not, they can go back and keep working until they do. And most of these are self-checking. I think this one is too, but this one will ask them to explain. Yeah, it actually is not self-checking, because if you explain, it's not going to show anything but a dot. It will show an X, though, if they pick the wrong one. So in that way, it does help them. And then this one, what is the common difference? So not what is the next term, but what is the common difference? This one, they're drawing the first five terms. I would definitely look at student graphs and see if they're connecting their dots, or if they're starting at 0, because you don't want that to happen. I put some teacher moves down here, and I've given you the order pairs of the first 5 points that should be displayed in this graph. They can use this little pencil tool and just hit it, lightly to make a point like that. They can click here to exit out and start over. This one asks for the 45th term of the sequence. So some kids are going to actually try to count up to the 45th term of the sequence, which is terribly inefficient. See if you can encourage them to maybe come up with kind of an expression to use for that. I did give them the graphing calculator up here, so I'm sure some will take advantage of that, but you may ask some kids how they could find that without counting all the way up to the 45th term. Here is an equation. They're going to use the subscript notation to represent. So this is a reminder of how to do that. That was in their slides, so you could refer them back to that. But the subscript notation will work in Desmos in pretty much the same way, and it looks something like that. And then this is a card sort. They're going to match a graph to an equation to a sequence. All the graphs are very similar, so to see them better, tell them to click on them, and they will be enlarged so they can get an up-close look at the values that are in those points. And this is the fun part of the activity. They're going to do a polygraph. I honestly can't show it to you because you can't really do it unless you have a partner and you're in as a student. But I will say this gets very noisy, and it is extremely fun, especially the first few times that you do it. It's a way of drawing the vocabulary out of kids. So you'll notice that some of these graphs are continuous, some are discrete, some are linear, some are nonlinear. Some of these could represent a sequence, but some of these could not represent a sequence. And so you want to talk about that. And here are some suggestions I put down here in the teacher moves. What I do is while they're playing, if I hear a kid use a word like discrete or use a word like linear or any kind of mathematical vocabulary, I immediately go write it on the board. You may even give them a prize for doing it, because the more of this language you can get out of them, the better they're going to be able to use that word, those words in their descriptions. And really, it's better communication in general to use the correct vocabulary, the mathematical vocabulary. So I've listed out some keywords that you probably should hear. You may not be hearing them initially, but as they go through this activity and play 1 or 2 rounds, maybe by the end of the second round, more of the kids should be using these types of words: increasing, decreasing, linear, nonlinear, an arithmetic sequence, slope, rate of change, discrete, continuous, quadrant 1, quadrant 2, x-axis, intercepts, those types of words. So anyway, as they're playing, solicit those words. Try to get them to say those words. And the more they say, the more you can write up on the board and make a list of the words as they're using them, and praise them for using that rich vocabulary as they play this game, which is quite fun. So that concludes our sequences and patterns assignment. If you have any questions about the tasks that are in this assignment, let me know. If you have any suggestions for an upcoming assignment, an activity that you'd love to see, let me know. Y'all have a great day.